In this video, we're going to do 8.05 tomato. Alright, so I already have the file opened up in DrRacket, and this problem has two subproblems A and B. But let me show you guys what this program looks like before you implement it. So let me just run this. It's just going to have a tomato starting from the left side of the screen, and then it just rotates and it looks like it's being thrown all the way to the right side of the screen until it goes off screen, and it kind of just goes on forever, right? Alright, so let's go back to Racket here. Alright, so design a world program that rolls a tomato from the left side of the screen to the right side, right? Use this tomato emoji with text for an image of a tomato. Call your compound data tomato, alright? So even though this can be done with compound data, we encourage you to use a structure definition, right? So anywho, pause the video and try to work it on your own, right? Follow the htdw steps of the domain analysis and sketching it out and then building the actual program. I'm going to go over spoilers in 3, 2, and 1. All right, so here's my domain analysis to basically sketch out what we need to do, right? So let's see. So the width, height, background, center X, center Y, tomato image. So that's already defined for us right here, right? And then the rotation speed for, how fast it's going to rotate. And then the speed X is how fast it's going to travel across the screen, right? The changing information is the X and the rotation. And then the Big Bang options identified is the onTick and to draw. But anywho, let's just start off by typing out the constants. So I'm going to say this is going to have a width of 300. You guys can do something different. And the height of 200. Actually, I'm going to make the width 400. So a little bigger. All right. You guys can choose any numbers you want. All right. So tomato image. So we always want this centered. So center up. Define center X is the width divided by 2, and then the same for center Y. So there we go. So it's going to be the height. All right, what else was a constant? I'm going to go down here now. Oh, the background. So I'm just going off memory here, but we're going to flip back in a second. Empty scene of width and height. What else? Center X, center Y, tomato image, rotation speed, and speed X seem to be the last two that we're missing. All right, so define rotate speed, we'll say of 4, and then we'll say the speed X. What? X. Speed X, yeah. X is going to be 4. All right, or X speed, whatever you want to name it. There we go. So those should be all the constants. Maybe we'll identify more as we work through the problem. But that is the constants done. Let's move on to the data definition. All right. So try to pause the video and work through this on your own. We'll go over spoilers in 3, 2, and 1. All right. So assume that you guys gave it a good swing. So it says to call our data definition, right? Our compound data definition, tomato. Don't get this data, confused with the image of tomato, right? It's just the structure definition. So define struct. We want a model, which is a tomato, and it's going to have to contain an X position, right, to represent where it is in the horizontal direction of the X plane. So, this way, right, and then the rotation because it has to, keep on turning. So we're going to call that an angle. You can call that whatever you like. I'm just going to choose X and angle. All right, next is how to make a tomato. So tomato is make tomato. They're both going to be numbers. So I guess X is the natural number because it only goes from left to right. But, let's just both make these numbers. Number, right? It's not too inaccurate. All right, next is the interpretation. So X is the horizontal position of the tomato. And then angle is clockwise rotation of tomato in degrees, right? So it's measured in degrees. Let me just check myself off for those steps. So that is the data description. That's the interpretation. Could write out these structure signatures here. So it's going to be something like tomato-x, and that's going to assume a tomato and then produce a number. That will get out the X position. Same with the angle. So tomato dash angle, when given a tomato produces the angle of that given tomato, right? So next, let's come up with some data examples. So we're going to say define. Let's say T0 is going to be make tomato 0, 0. So a tomato that is, starting way at the beginning. So I'm going to make a comment here. Starting way at beginning. Well, starting way left with rotation 0. All right, let's do another one. So we'll say, something like T1 is going to be make tomato. We'll say half the width. So that's the center X. All right. And then let's see. Actually, we don't really need the center X in this constant, right? So let's go back to our diagram here, right? The X is always going to go in this direction, right? We only want to center it in Y. So we don't really need the center X as a constant, but we made it as a constant anyways. So we might as well use it, right? It's not too otherworldly to like define it as a constant. We could write, if we didn't define it, we'd have to do like slash width divided by 2, but hey, we have it, so we might as well use it. All right. So let's see, that's the X position. So it's in the middle of the screen, and then we'll say 45 degrees. All right. All right, so tomato, middle of the canvas, all right, with rotation of 45. All right, so those two should be enough examples for now, right? Next is a function template that processes this data, all right? So any function, we're just gonna layer all the pieces. We'll call it TM, all right? Any function we write that consumes and process a tomato, we'll probably want to take apart its components, such as the tomato's X, right? So given tomato, get its X out, and given a tomato, get its angle out, like so. And we will use this as a baseline. But anywho, that is the htdw steps done. Now, let's move on to functions, all right? So let's see, there we go. All right, so let's go back to our sketch here. So big bang options, on, tick, and to draw. So there's no mouse interaction, so we don't need on mouse. We don't need stop when. We will need on key for problem B, but we're going to get to that a little later. Let's just focus on problem A for now. All right, so let's start changing these WS signatures to what it is now, right? It's going to be a tomato. All right, we're going to use that structure. I'm going to find WS and replace it. So show replace tomato. There we go. And replace. We're going to skip those for now. Replace. Just these signatures are fine. Like so. All right. And then we'll fix the TM right now. All right. Just to make it a little more clear. All right, so now let's go through the HED steps, right? For the to-do list, we have to do this talk function and then the render function. So pause the video and try to take a swing at the talk function, all right? I'm gonna go over spoilers in 3, 2, and 1. All right, so maybe this should be better named because talk doesn't really, indicate much. It just rhymes with tick, so we know that it's gonna run every tick. But let's just change it to, advance tomato. Right, because it's more descriptive and representative of what this function's purpose is, right? So there we go. I got to change this there too. Okay, so the purpose, so that's the signature. Next is the purpose, all right? So produce tomato with increased X and rotation. All right, so next is the stub. So let's see, advanced tomato consumes a tomato and has to produce a tomato. So at minimum, we know that we have to produce a tomato, and this is the only way to do so. I make tomato of 0, 0. That seems like a good stub. Next, let's write our examples. Advanced tomato. All right, so if we're given T0, which is this, right? Make tomato 0, 0. So just scroll up and find it again. Right over here, right? Starting way at the left with a rotation of 0, right? We want to increase that by the rotation speed and the X, the speed X. So let's just do that. So we're going to have to produce a tomato, right? And really, we got to increase the X by the speed X. So what is the speed X? It is 4. So this should produce a tomato of 0 plus 4, X, and plus 0. I think 4 was also the rotation speed. Yes, it is, right? But we can do better than those. I mean, than this, because we can just use the constants. So speed x and rotate x. So in case we change the constants, right, we want it to go a little faster or something, well, we don't have to worry, right? Let's do one more example here. All right, so there we go. And let's make it of t1, right? And I forgot what t1's coordinates were. So t1, here we go. So it has a center x and 45, all right? So we're going to add center x. So it should be center x and then incremented by the speed. And the rotation was 45 degrees. Right, all right, yeah, we're going to take that 45 out and add it with the rotation speed. All right, so I'm going to really pause the video and try to work through the solution on your own. All right, I'm going to go over spoilers in 3, 2, and 1. All right, again, that should have been the mental scaffolding, most of the mental scaffolding needed. You still have to do the template here. All right, so I'm going to comment the stub out. And let's take the template from the earlier steps and use it as a starting baseline. So there we go. Copy and paste this down. It's going to be called advanced tomato now, and we want to do something to these components. All right, so again, pause the video and try to work this on your own. All right, so let's go over the solution. So let's see. We know that it has to produce a tomato, and the only way to do that is to use make tomato. And we have to add it, right? We have to take the x of the given tomato that's coming in, and then spit out a new tomato that is incremented by the speed x, all right? And same with the angle. So plus, and then we'll do something like rotate speed. All right, so there we go. All the tests should pass. And let's see, text expects only 3 arguments, but only found 4. Oh, this solid was not needed. All right, don't worry, they'll be fixed when I fix the problem, right? So for those of you who are going to download this problem in the future, don't worry, this should be fixed, right? It didn't really need this solid argument right over here. It only takes 3 arguments, right? The text itself, the size, and then the color. All right, so now let me run it, and all the tests for advanced tomato should pass. And so they do, all right? All right, so now let's move on to the render function. So pause the video and try to work through the render function on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So this function's job is to produce the image of a tomato on top of the background at the given x coordinate with the given rotation, right, of the given tomato. All right, a little bit wordy, but, you know, better to be as precise as possible. All right, so let's work on the stub. So render is going to have to produce an image, and we can use, you know, a lot of things for this, but empty image is the simplest thing right now. So empty image, there we go. All right, so next are some examples. So check expect render, we're going to say of make tomato 0, 0. All right, so that's starting at way at the left, right? But we're going to do a place image of the given tomato. So we're going to say, let's see, rotate the tomato by its tomato dash. I'll rotate it 0 degrees because that's where the that's the rotation, right? And then we're gonna have to take the tomato itself, tomato image. There we go. All right, so then we want to place it at the, not the center x, but the x right over here. So this is the x position, which is also 0. All right, and then center y. All right, there we go. Let's keep going. Center y. And then on top of the background. All right, let's do one more for the fun of it. All right, so let's use, you know, we can also, you know, take these from the constants, but I'm just going to inline it here so it's easier and we don't have to scroll back up and back and forth. All right, so we're going to say center x is where the tomato is. Center dash x. Hopefully that's a variable. Center dash x. Yes, it is. I didn't get the autocomplete, so I was like, huh, does it not exist? All right, so center x, and then we'll say rotated 45 degrees. All right. So that means we want to take that 45 from the tomato and stick it here. And the X, we want that to be there, stuck there. All right, so now if I run these tests, we should see, some example images. So that's the tomato all the way from the left, starting from 0, 0. And here's one starting way in the middle, right, rotated by 45 degrees. All right, so it seems like, no typos, just mismatches. So let's just grab the template from the data definition right over here and use this as a baseline. All right, so I'm gonna comment out the stub. There we go. And I'm just gonna paste this down here and rename this render. All right, so now really pause the video. This should be all the mental scaffolding needed to solve the problem. I'm gonna go with spoilers in 3, 2, and 1. All right, so I'm assuming that you guys took a good swing at it. So this has to produce an image, and we already sketched this out in our test here. So we do a place image of the rotated tomato. So we're gonna do a rotate here, rotate. And since this is the changing argument, we have to stick something that changes here. So we're given a tomato, we got to take the angle of that tomato and then rotate the given constant, right? That is that tomato image. Again, don't conflate the image of a tomato with the data structure of a tomato that has an X and an angle. All right, so rotate this, place this rotated image at this X coordinate, all right? And then center it on the Y axis and then put this on top of the given background. So this should work. Let me just Control R and run it against our tests, and all 4 tests pass. All right, so let's just scroll back up and we can start main with main make tomato 0, 0. All right, also with like main T0, because T0 is a variable that holds make tomato 0, 0. But either way, if you don't have that constant defined, you have to type the long way. So there is our rotating tomato. So just run it again. So there we go. And it's rotating like at the different angle than you expect, right? So we can change that by making the angle, right, the rotate speed negative. Because it's rotating counterclockwise. We want to rotate it clockwise since it's being thrown from left to right. So, it's like we expect the arc to go something like this. All right, it should like have that angular velocity. All right, so there we go. If we run it and then run main Control P to get our previous commands back, right? So there we go. Now it should rotate clockwise, like so. All right, so there we go. That is pretty much done for problem A. Now let's move on to problem B. Reset the position of the tomato to the start when the R key is pressed. All right, so pause the video and try to take a good swing at that. All right, so I'm assuming that you guys took a good swing at it. So let's go over the solution. So we're going to need the on key clause from Big Bang, and we're going to need to handle this key. All right, so there we go. We can always start and take the template for the handle key function. So let's see, scroll down. So let's see, here's the handle key function. That's something we'll need. So let's just copy and paste it down here. All right, so there we go. So here's the handle key. It has to consume a tomato now. So there we go. And it also has to produce the world state, which is the tomato. Right, and we'll change this to TM and TM for all the other world states, like so. All right, so handle key is, problem B is, when we press the R key, it has to, go back to the beginning. So produce tomato of 0, 0. Produce tomato at the left with rotation 0, with no rotation when R key is pressed. All right, so let's write some examples now. So check expect. All right, and let's see, handle key of, let's see, T0, and then I'll say T1. T1 is like, I'll just write it out. Make tomato, it doesn't really matter what the coordinates are. Let's see, make tomato 42, 23, right? And we press the R key. Well, this has to produce the reset tomato, which is the 0, 0, right? The one with 0x and 0 rotation. Let's just do one more for good measure. So let's say we press the space key or any other key, right? And let's just swap these coordinates for more variety. So we press the space key, right? Nothing should happen to this tomato. We should produce the same tomato. So 21 and 43. All right. So there we go. All right. So now let's just quickly turn this into the stub. So we know we have to make a tomato of 0, 0. All right. Or, we can do something like, hey, since we're given a tomato and we have to produce a tomato, instead of using this, right, we can use tm, right? Just pass back the output tomato. All right, so now let's run against the stub, make sure there are no errors. This just mismatches like so. All right, so now really pause the video and try to work through this problem on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, so hopefully that should have been most of the mental scaffolding needed. So let's see, if we press the R key, we need to produce the 0 tomato. So our examples just kind of hint towards that. And otherwise, we just have to produce, just throw back the tomato that we gave, right? So we gave it the tomato of 21, 21. And hey, if I press any other key other than R, just give me back that tomato with the exact same dimensions, like so. So if I run it, and then run main of make tomato 0, 0, there we go. When I press the R key, it should reset all the way back to the beginning like so. And when I press any other key, it doesn't do anything. All right. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on the screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.